Hey class, so here's the lever design problem. This is a challenging problem because you're not given two pieces of information, which means you need to do a little designing. If you look at this, right, looking for a mechanical advantage of 10, and we're given a distance here. So that tells me that, oh, this is probably going to be an IMA problem. And we have an 8-foot board. So if you do this, and I gave this hint in class, that it's harder if you do this as a first class lever, because if you do this as a first class lever, you have FR over here and FE over here, and this whole thing has to add up to 8 feet, which gets a little tricky because if you do this as like split this as 7 and 1, well, that gives you a mechanical advantage of 7, so that's not enough, so you know you need to go shorter, right? So you can try like 7.5 and 0.5, and that actually gives you a mechanical advantage of, so that'd be 14, yeah, like mental math, 15. Sorry. So, which would do the job, right? But this is easier, like I said, if you do this as a second class lever. Because if you do this as a second class lever, let's draw this out here. So our fulcrum here, our effort here, and we need a big mechanical advantage, so our distance resistance is going to be somewhere down here. Well, then we know that this whole thing is, I'm just going to use the whole 8 feet of the board. So that tells me, okay, so my DE is equal to 8 feet, and that means I'm trying to solve for DR. You can do this as a first class lever, it's a little bit trickier. And I think you need something like, I don't know, like 7.3 and 0.7 to split it. Ends up working. But I'm going to go through the easy solution here because it's good enough for us, right? And if you want help on the first class lever solution, let me know. And our IMA is equal to 10. So again, we go back to our IMA equation. And substitute in. And because I'm just using the full 8 feet as the effort distance, it makes this problem a little bit easier to solve. There's no like subtracting sides and figuring out how much is on this side or that side. And it becomes like the last problem I showed you, where we just have to solve for dr by getting that to cancel out and move over here. So dr times 10. And this is very much like the other problem. And then we just divide by 10. And we find out dr is equal to 0.8 feet. And you could, of course, convert that into inches. But looking at those numbers, like, oh yeah, 10 times as much effort distance is going to make us 10 times stronger. So we can lift this rock up. So a little bit tricky. It's very much, the math is the same as the last one, but there's that extra step of having to like read through this and realize what's going on, which makes this like a level 3 or harder problem, since you have to kind of make some choices and it's not just pull the information straight out of the problem. Even though it is kind of all there, you have to think a little bit more on this. So this was a challenging problem if you haven't done one like this before. Hopefully this is helpful if you see another one like this.